take number how manyth? I don't even know. I tried to explain it in a certain way and I think I tripped up a bit. Hello, this is Electrostatics. I want to explain what electrostatics is. What are we actually looking at before we begin? So electrostatics, as a rule, just means the study. This is the study of electrically charged objects. That's literally all it is. So yeah, by charge, what do we mean? Well, something can have a positive or a negative charge. It's very similar to a magnet, right? You have a north and a south side that are different. So charge is just a measure of electrons, which I'll show in a minute. Do I even have a different height? Okay, I wanted to make this blue, but this is just going to be green. In the same way that magnets have to do with a measure of some kind of property that kind of causes some force between like or unlike sides. So if we have a magnet like this, I'm just going to make this red like this. I know it's not the same, but oh well. Then this is just intuition as we've learned throughout the years. Since a child, you kind of play with magnets and stuff. You realize, oh, the different sides attract each other and the same sides repel each other, right? Now, this is kind of the same to do with electrical charges, but it's not the same as magnets. Magnetic charge and electrical charge are different things. Electrical charge has to do with the amount of electrons in a certain space, which I'll show in a moment. And magnetism or magnetic things have to do with the exact kind of atoms or the kind of elements. For example, a metal is magnetic, right? But a candle, there's a candle in front of me, a candle is magnetic. But yes, that's just, I digress there. But to start, let's look at an atom. Here is an atom. I'm going to draw it like this. We have a bunch of things in the middle, in the nucleus, which you will be familiar with. Then you have electrons that orbit the nucleus. And these are here. I'm just going to say E. And then you have protons, which I'm going to designate with a plus. And then you have neutrons, right? So you have protons, neutrons, and electrons. Now, we know that the amount of protons and neutrons, they kind of decide what element it is, right? So just as an example, I'm just showing here, in the periodic table of elements, just by the way, I know we're doing physics, but it is all connected, man. You have the numbers up here. These refer to the amount of protons, okay? So basically the amount of protons a kind of atom has dictates what kind of atom it is. So if I just go back to this, my point is if we wanted to change the charge of an atom, we won't go removing the protons from its nucleus, nor will we be removing the neutrons. These are going to stay there, okay? And this would mean that if we had no electrons, this thing would be really positive all the time, because the rule about protons is they carry the positive charge. Electrons, they carry the negative charge. Why we say this is that's just the names we gave these types of little things, right? We decided that whatever this electron thing is, we're just going to call it negative. Whatever this proton thing is, we're just going to call it positive. All we know is that they are opposites. So if you just want to know where they come from, that is what it is. But how we can change the charge on an atom and thereby kind of change the charge on an object, which would be full of one kind of atom, we can't really change the protons. We can't remove a proton to make it, less positive. So if there are 5 protons and 5 electrons, which are, make it like 5 electrons, then, 5 positives are like equally balanced with the 5 negatives. Oh, this is very terrible writing. And then you imagine, okay, it's neutral at the end, right? 5 positives, 5, so a positive number of 5 minus, minus 5 is 0. But if you want to make it more negative, you can't go removing a proton to say, okay, there are 4 positives and 5 negatives, so obviously the negative will win. There's more negatives. Because then you will have this change to a different element, which is what the idea of alchemy in the ancient times kind of was. You want to change one kind of element to another kind of element. Not possible, theoretically, physically, So I'm not going to go change this, let's say it's nickel or copper into hydrogen suddenly just by removing a few protons. That's not practical. So instead, we control the amount of electrons. Electrons can actually easily move over to other surrounding atoms sometimes. So that's why you have the thing where if you sometimes touch two things, like you have a balloon that is filled with electricity, or it's just like it's when you just rub your hands on a balloon and you're wearing gloves, and then suddenly when you touch to someone there's like a spark. That is due to the difference in charges. Suddenly a bunch of electrons are jumping from one object to another when they touch. I know this is a bit of a roundabout way to explain it, but I just think it's important to know what we are actually studying, where these forces come from. So what's happening here is we have 2 metallic bricks here made of metal. And because everything is made up of atoms, these atoms will have a certain amount of electrons and protons. If there are more electrons and protons, then something will be slightly negatively charged. If there are more protons than electrons, this will be slightly positively charged. It's an interesting thing. Is a field of study called semiconductor physics. It's not important to probably know, but it's just interesting to me. Literally, where all our electrical chips in phones and stuff come from is because of something called doping. Doping means we are actually physically just adding a bunch of electrons to something and changing the charges of it. I just bring it up because it's literally something we do and use every day, is adding charges to something or removing charges, You add electrons or you remove electrons. So this isn't something you need to physically know. I just wanted to say what is going on, where these charges come from.